This video will cover how to graphically multiply two functions together to create a new function of a higher degree. So here we have two functions, h of x and L of x, and we are going to create a new function that is the product of those two multiplied, and graph that new function. Information that is given to us in the problem is that the equation for the blue graph is h of x equals x, and the equation for the purple graph is L of x equals negative 2x plus 8.5. So the first thing we can do is mark the x-intercepts of our new function. The x-intercepts of the new function are going to be the same as the x-intercepts of the old function. So we'll have an x-intercept here at 0, 0, and one at, it's not an exact number, but it's a little bit more than 4. So we already have 2 points for our new product function at the x-intercepts of our old functions. So there's some dashed lines here to show how the x-intercepts divide the coordinate plane into regions. So we have this region which is labeled A, this region B in the middle, and this region C on the right side. And what we want to do is calculate a point on our new function in each of those 3 regions. So let's start with the leftmost region. We can pick any number for x that's in this region. So we can pick anything less than 0. So let's pick x equals negative 1. So now we're going to calculate what is the value of our h function when x is negative 1, and what's the value of our L function when x is negative 1. So for my h function, I can actually just look at the graph and see when x is negative 1 on the blue graph, y is also negative 1. That makes sense because my equation is h of x equals x. So if I'm plugging in negative 1 for x, I'm also going to get negative 1 as the output. So h of negative 1 is negative 1. This notation means that in the h function, when x is negative 1, y is also negative 1. Now let's evaluate the function, the purple L function for negative 1. So L of negative 1, I'm actually not able to see that on the graph, so I'm going to have to use my equation. So negative 2 times x. As x, I'm plugging in negative 1, so this is negative 2 times negative 1 plus 8.5. You could use a calculator to do that, and you would end up with 10.5. So we figured out what the y values are for our two original functions when x is negative 1. Well, the new function that we're making is the product of these two functions. So we are going to multiply together those y values. So the y value of our new function is the product of our two old y values. So this means that our new product function is going to have a point at negative 1, negative 10.5. So I can add that to my graph now. Negative 1, negative 10.5 is just a little bit off the graph, maybe right around there. So we're going to repeat that process for each of the regions on the graph. So now we're going to pick some number for x between 0 and this is a little more than 4. I'm going to pick 2. So h of 2, I can see from the graph that when x is 2, the y coordinate on the blue line is also 2. Let's get L of 2. So again, our equation was negative 2x, so negative 2 times 2 in this case, plus 8.5. You could use a calculator to evaluate that, and you will get 4.5. My new function is the product of these two old functions, so I'm going to multiply. Oh, I abandoned my color coding. I'm going to multiply 2 and 4.5 and that will get me 9. So my new product function is going to have a point at 2, 9. So I can add that to my graph right here. Now we're going to do one more point in this right region. So we can do anything that's greater than a little bit more than 4. So maybe I'll pick 6. So for h of 6, I'm going to look at the graph and see when x is 6, y is, let's see, also 6. That makes sense because our function is x. So just want to emphasize again how you can get the y values from a graph when you're able to. You want to go over to that x value. So I'm doing 6 as x. And then you want to go up or down until you hit your function and see what is the y value there. So on this graph, on the blue graph, when x is 6, y is also 6. So h of 6 is 6. For L of 6, I'm going to have to use my equation, which is negative 2x, so negative 2 times 6 plus 8.5. Oops, this is actually negative 3.5. This is why you should always do math in pencil. So when I multiply those together, I'm going to get negative 21. So I'm going to have a point at 6, negative 21. And just to emphasize that this x value of 6 is coming from the fact that I chose 6 as my x value to plug into the function. So it's not coming from like the output of h. This x coordinate is going to be whatever you chose as x to plug into your functions. So that is going to be way off my graph. Please ignore this point that I drew by accident. And I'm just going to put a point as far down as I can, knowing that it'll actually be much farther down than that. So I should have enough points now that I can sketch my graph. It needs to go through all the points that I plotted. So it needs to go through here, through that x-intercept, all the way up to here, and at some point turn around and go back down through this x-intercept and all the way down very steeply like so. So just to summarize that process, your first step is to plot the x-intercepts to create regions. So I plotted those x-intercepts from the original graphs, also the x-intercepts from my new product graph, and that divides the coordinate plane into these regions. Then you're going to choose a value for x. So the first one I chose was negative 1, and you evaluate each function for that x value. So I found out on my h of x graph, when x is negative 1, what is y? And then on my purple L of x graph, when x is negative 1, what's y? You multiply those results together to get your new y value, and then you plot your new points with the x value that you had chosen to plug in and the y value that you got from multiplying. Step 3 is to repeat this in each region. So we found a point in the left region here, in the middle region, and down in the right region here. And then you want to draw a curve that goes through all the points that you plotted. This is the exact same process you would use even if you had 3 original functions that you were using to create a new cubic product function. You would go through the same process, you just might have a few more x-intercepts or a few more regions. So that is the process for graphically multiplying 2 functions to create a new function.